Alrighty, welcome to the video on practicing multiplying polynomials, and then we're going to also learn an introduction to factoring, both factoring common factors as well as factoring quadratics, which is kind of exciting because that's going to make your life a lot easier when we get to chapter 9 and deal with quadratic functions. So we're going to start off here multiplying polynomials. In the previous video I talked about two methodologies, one was FOIL and one was distribution. So I'm going to review those two briefly, and then I'm going to introduce a third option called a rectangle diagram. Which is another way that you can multiply polynomials together that helps you kind of keep track of your different terms. So let's start off. Where's my mouse? Start off reviewing FOIL. Here we go. So we're going to multiply the polynomial 2x plus 1, that's a binomial, times the binomial x minus 4. So remember to do FOIL. It stands for firsts, inners, outers, lasts. So I like to write it down like this so I can clearly show all my work. So I've got firsts, inners, outers, and lasts. So the first one means the first term here times the first term here. So 2x times x is 2x squared. 2 times 1 is 2. X times x is x squared. Again, you always multiply the numbers first and then the letters together. Outers is going to be the 2x and the 4. So 2x times negative 4. Now you have to be careful because this 4 is negative. That negative sign is attached to the 4. So 2x times a negative 4. 2 times negative 4 is negative 8. And I've got an x here and no x's here, so I just have x to the first power. Inners is positive 1 times x, so that's just 1x or x. And last is going to be positive 1 times a negative 4. Positive 1, negative 4 multiplied together gives me negative 4. Notice that I used each thing twice, okay? Because everything in here is getting multiplied by everything in here. That means all my terms are going to get used 2 times. Now, I've got all these 4 pieces that I need to add together. I need to add all these pieces together. So 2x squared, that's simple. That's just 2x squared, because all of these 4 pieces, the 2x squared, it's the only term that has x squared, so I can't combine it with any of the other ones. Okay, when I look at my negative 8x though, and I see this 1x right here, I should see that these are like terms. They both have x to the first power, so I can combine them together. Negative 8x plus 1x is negative 7x. And then this negative 4 right here is all by itself, negative 4. So that's my final answer, 2x squared minus 7x minus 4. I can't combine any of these because this has x squared, this has x, and this has no variables. So none of them are like terms. Okay. An alternate method to this problem, so notice it's the exact same example, is to use the distribution technique. So distribution means everything in here has to multiply by everything here. So first I'm going to distribute my 2x, like 1 and 2, just like you would normally distribute. So 2x times x is 2x squared. Okay, 2x times negative 4 is negative 8x. Then I'm going to distribute my 1, okay? So I always do these on the bottom just so I can clearly keep my work shown. 1 times x is plus x. And 1 times negative 4 is negative 4. And you can see that these 4 pieces that we got by distribution are the exact same 4 pieces that we got by doing first, inners, outer, last. There's just different ways to show your work in order to make sure you get all the possible combinations. So whichever way you think is easiest. Now you can clearly see that these two guys are like terms which can combine. So we get 2x squared minus, minus 7x. Again, because negative 8 plus 1 is negative 7. Keep the variable the same. And then minus 4. So that is another way to do it. And the third way, this is a new method that I haven't actually taught you guys yet. So I'm going to use this video to explain it. The idea is you draw a rectangle, and the size of the rectangle is going to be based on the number of terms here and the number of terms here. So I have 2 here and I have 2 here. So I'm going to draw a rectangle. And I'm going to make my rectangle 2 by 2. 2 by 2. And then this term here, I'm going to write down the side. So 2x is my first piece, so I put a 2x here. Let me just draw a little line so I can differentiate these problems from each other. Okay, so I put a 2x here, and then I put a plus 1, so I put a 1 right here. Then across the top, I'm going to put the pieces from this term. So I've got an x in the first column, and a negative 4 in the second column. Okay, and I'm going to fill in all of these boxes by cross multiplying well, not really cross-multiplying in the sense that you've learned it before, but multiplying whatever's in this row by whatever's in this column. So this one is going to be 2x times x, which is 2x squared. This one here is going to be 1 times x, which is just x. This one here is going to be negative 4 times 2x. 2x there, and negative 4 there, so negative 8x. And this one here is a 1 and a negative 4, for a total of negative 4. And then just like in the previous example, I had 4 pieces here that were all the same as these 4 pieces here, which is the same as these 4 pieces here. I need to add these pieces together, and I get 2x squared. These two can combine with each other, so I use that guy by himself. These two combine together to give me my negative 7x, and this guy is by himself. So you can see that no matter which way you choose to do it, obviously you get the same answer. You can use whichever one you think is easiest. Personally, I like to use this one because I think it requires the less amount of space. But if you're more comfortable with these other methods, by all means, you're encouraged to use them. So I'm going to do one more example using each of these 3 methods, but I'm going to do a different example for each one. Okay, so here we go. We're going to do this one using FOIL. So here's my F, here's my O, here's my I, here's my L. So first is going to be x times x, which is x squared. Outer is going to be x times 9, which is 9x. Inner is going to be negative 3 times x, which is negative 3x. And last is going to be negative 3 times 9, which is negative 27. Okay. Now I add up these guys, and I see that these two are like terms, which can combine. This will happen a lot, where the middle 2 terms are like terms. Not always, but very often the middle 2 terms will combine. So my final answer is going to be x squared, positive 9x and negative 3x combined to give me positive 6x, and then minus 27. Okay. So this is my final answer for this problem. So there's another example using FOIL. First, inner, outer, last. Make sure you multiply all 4 pieces and then combine like terms and add these all together. Okay, our second example is going to be using distribution. So I'm going to distribute this into here and here. So first is 3x times 3x. That's this arrow right there. So that's going to give me 3 times 3 is 9. X times x is x squared. Then I follow this second distribution arrow, which is 1 times 3x. So that's a positive 3x. Okay. Then I do this guy times this guy. Negative 1 times 3 is negative 3x. And last, I do this guy times this guy. Negative 1 times positive 1 is negative 1. Okay, these two guys, not only do they combine, but actually they combine, of course, but they actually cancel. So they combine to 0. So what's my final answer? This guy is left over, and this guy is left over, but the middle 2 pieces, they cancel out. So my final answer for this problem is 9x squared minus 1. This is called a difference of squares, and we'll talk about this actually probably in another lesson. Alright, and our third example problem is going to be done using rectangle diagrams. I'm going to move over and just give myself a little more space. So in this guy, you can see this has 2 terms, and this has 3 terms. So my rectangle, I'm going to need to make it 2 by 3. So I'm going to make it kind of big, just to make sure we have enough space to show all of our work. So down this side, I have an x and a negative 12. And on this side, I have an x squared, a 4x, and a negative 3. So you're literally just writing down these 3 pieces across the top and these 2 pieces down the side. Now to fill in the table, again, you have to multiply everything together. X to the first times x to the second is x to the third. X to the first times 4x is 4x squared. And x times negative 3 is negative 3x. Okay, negative 12 times x squared is negative 12x squared. Negative 12 times 4x is negative 48x. And negative 12 times negative 3 is positive 36. Okay, now we add up all the terms. Now, x cubed, this is the only thing in it that has x cubed. Out of these 6 pieces, it's the only one with x cubed. But the x squareds, I actually have 2 terms that have x squared. So these two I'm going to combine. Negative 12x squared plus 4x squared. Negative 12 plus 4 is negative 8. And negative 8 what? Negative 8 of this piece x squared. Okay, when I go on to x to the first power, again I have 2 terms that can combine. Negative 48 and negative 3 combine to give me negative 51, and it's quantity x. And finally 36 is all by itself, so plus 36. And there's my final answer. So you can see throughout these examples there's lots of different ways to do it. When you have a 2 by 2, you can use FOIL. And you have any other dimensions, you cannot use FOIL. So that's important to remember. FOIL only works on a 2 by 2. Rectangle diagrams work for anything, and they work particularly well for really large problems where you want to be able to keep track of all your terms. And then the distribution method where you draw on these arrows, it's the quickest, but it's also the easiest to make a mistake. So only move on to this method if you're feeling really comfortable and you don't have to show as much work. Alright, we're going to move on now to factoring, which is undoing distribution. So let's take a look at that. Alright, factoring common factors. Here we go. So I've already got this thing prepared. When you do factoring common factors, the idea is you're trying to undistribute. So when you distribute, you've got one number outside the parentheses and then a bunch of stuff in the parentheses, and you distribute it in, and it multiplies to everything inside. So what that means is all those numbers inside, they now have something in common. Whatever that thing you multiplied in, they have that in common. So you could take what they had in common and take it back out and see what you had left behind. So that's the idea with factoring common factors. You find out what the terms have in common. Oh, let me get my pen here. Okay, you find out what the terms have in common, and then you take it out. And when I say factor it out, that means you divide all the terms by that quantity, because you're undoing distribution. And remember, distribution is the same, is another way of saying multiplication. So factoring out is division, distribution is multiplication. In fact, let me write that because that's really, really important. So distribution is multiplication. Factoring is division. Okay, so cool, that's important. Now, how do you do this? You put the common factor, whatever they had in common, outside the parentheses, and then you divide each term by whatever that factor is. Instead of multiplying it in, you divide it out, and then you write down whatever's left. So at the end of the factoring problem, it's going to look like the beginning of a distribution problem, and at the end of a distribution problem, it's going to look like the beginning of a factor. So they just go back and forth between each other. So let's take a look at some examples. When I look at these terms, 4x squared, 20x to the 6th, negative 2x squared, and 10x to the 6th. What do they have in common? So you ask yourself, first look at the numbers. Okay, so we need to find what these terms have in common. They've got a 4, a 20, a negative 2, and a 10. So that means the biggest number that they all have in common is a 2. And now look at the variables, x to the 3rd, x to the 6th, x to the 2nd, and x to the 8th. The biggest thing they all have in common is an x squared. So this one has 2 x's in it. All the other ones have more than 2 x's. And by 2 x's I mean x times x. X multiplied by itself 2 times. But all the other ones have more than that. But the biggest thing that they all have is x squared. So now we see, what do they have left behind? Well, each of these terms needs to be divided by 2x squared. So 4x cubed over 2x squared plus 20x to the 6th over 2x squared minus 2x squared over 2x squared. That was the biggest term they had. Plus 10x to the 8th over 2x squared. And once you get the hang of this, you're absolutely not going to need to write this denominator into all four pieces. You can just do it as you go in your head. But for the first example, I think it's important to see what we're doing. We took this out, and how we did that was by dividing each piece. So you can see that if you distributed this back in, this 2x squared would cancel out with all these denominators, and we'd be left with whatever we started with, which is good. But we factored it out, so now we can reduce each of these terms. So 4 over 2 reduces to 2. So I'm working here. Let me write this down again. I've got my 2x squared. 4 over 2 reduces to 2. X to the third over x to the second reduces to just x. 20 over 2 is 10. X to the sixth over x squared is x to the fourth. Negative 2 over 2 is 1. X squared over x squared is just 1, so it's still 1. Plus 10 over 2 is 5, and x to the 8th over x squared is x to the 6th. Remember, your rule for exponent is you subtract the exponents each time. So this is my answer. I've taken each of these four terms. I've seen that they all have a 2x squared in common. I've divided that out, and now it's divided out to the front, and what's left behind is each of those terms reduced by a factor of 2x squared. If I were to distribute this back in all the way to all four terms, I would recover my original starting problem. So that's a good way to check your answers, actually. Okay, now let's take a look at this guy. I'm going to do it right here. Okay, so look at what they have. I've got a negative 15, a positive 25, a negative 5, and a positive 15. I think it's easy to see they all have a 5 in common. Now look at the variables. A to the third, a to the fourth, a to the second, a to the fifth. The biggest thing they all have in common is an a squared. It's the highest power that they all share. Now we're going to try to go straight to the answer. If I start with negative 15 and I divide by 5, I'm left with a negative 3. If I start with a cubed, and I divide by a squared, I'm left with just an a. So it's easy to check, it's easy to check and make sure that that's right. Because if you remultiply these two things together, you'll recover this first term. So of course 5 times negative 3 is negative 15, and a squared times a is a cubed. So you can check the terms as you go. Second term, 25 divided by 5 is 5. A to the fourth divided by a squared is a squared. Third term, negative 5 divided by 5 is negative 1. A squared over a squared is 1. Fourth term, 15 over 5 is 3. A to the fifth over a to the second is a to the third. Okay? So there's not a lot of work you can show. I mean, you just kind of go straight to the answer, but it is a lot of steps, right? So first see what they have in common, then go through and divide each term by whatever that common factor is. Okay, now we're going to take a look at this guy, kind of going a little lower for each one. I've got 6b squared, 6b, 9b to the fifth negative, and 9. So what do they have in common? First, look at the numbers. You should be noticing a pattern where every time we do something, first we look at the numbers, then we look at the variables. A 6, a 6, a 9, and a 9. What's the biggest thing that those all have in common? What's the greatest common factor? They all have a 3 in common. Okay. Now look at the variables. I've got b squared, b to the fifth, and no b's at all. So actually they don't have any variable in common because this 9 right here, it doesn't have any b's at all. So there's no b's that they have all shared in common. So the only thing they have in common is that 3. So that's the only thing that I can divide out. So 6b squared divided by 3. So 6 divided by 3 is 2. But since I'm not dividing, since I'm not dividing any of the b's out, all the b's will stay the same. So 2b squared plus 6 divided by 3 is 2, and then the b stays there, minus 9 divided by 3 is 3, b to the fifth, and 9 divided by 3 is 3. Close those parentheses, and here's my answer. So you can see that this starting off problem looks very similar to this answer. All the numerical values have been reduced by a factor of 3. They've all been divided by 3. If I were to multiply this 3 back in, again, I would recover this original problem. Okay, let's do one more example. and then we'll be finished with factoring common factors. This is actually the easier type of factoring because you're just looking at what they have in common, and there's only one term that you're taking out. Okay, so let's look here. I've got a 3, a 10, a 10, and a 10. Is there any number that goes into both a 3 and a 10? No. So there's no number that they have in common, so I can't factor out any numbers. Okay, now let's look at the variable. Y to the 6th, y to the 5th, y to the 4th, y to the 3rd. What's the largest thing they all have in common? It's y to the 3rd. It's the biggest thing that they all share. Okay, so what's left behind? I'm not dividing by any numbers, so all these numbers, the 3, the 10, the negative 10, and the positive 10, the numbers will stay the same. It's only the variable that I'm dividing out. Remember that when you divide two variables with the same base, you subtract the exponents. So each of these little exponents up here is going to get reduced by how much? It's going to get reduced by 3, because that's how much I'm dividing out. So my y to the 6th, when I divide by y cubed, I get y cubed plus 10, because the second term is plus 10. Y to the 5th divided by y to the 3rd is going to be y squared minus 10. Y to the 4th over y to the 3rd is just y, and y cubed over y cubed is just 1, so I'm left with 10 times 1, which is 10. So notice that these powers decrease. 6, 5, 4, 3. These powers decrease. 3, 2, 1, nothing. Fantastic. Okay, so factoring common factors, see what they have in common, divide it out, write what's left. Okay, now we're going to look at a second type of factoring, which is factoring quadratics. So a quadratic is a special type of equation. A quadratic is a special type of equation that says some x squared plus some number times x plus some number. So this b and this c are positive or negative numbers. Okay, and the way that you get a result that looks like this is typically by through some kind of FOIL problem or distribution, actually a FOIL problem, first, inners, outers, last. The two in the middle, the inners and the outers, they always combine together, as you saw in the previous examples, to give you some middle number here. So working backwards to figure out what two terms created this is a little bit of a trick. But the way that you can figure it out is by remembering that to get that last number, you multiplied the last two numbers together. And to get that middle number, you did your inners and your outers, and you added the two things together. Okay, so the trick is to find two numbers that multiply to the last number. So we want to find two numbers that multiply to this value and add to the middle number, add to this number. Okay, so in this first example, our second number is 8, and our middle number is 6. So the best way to do these problems is to write an open set of parentheses like this, and to say, okay, to get my x squared, I know I have to multiply x times x. Now, to get two numbers that multiply to 8, what could I put in here? Well, not only do these two numbers have to multiply to 8, they also have to add up to 6. So in order to multiply to 8, I could do 8 times 1, or I could do 4 times 2. So you can list your possible combinations of ways to multiply to 8, and then you can say, okay, which of these combinations adds up to positive 6? And it's clearly 4 and 2, both positive, so positive 4, positive 2. So this right here is actually your answer, and if you multiply this out using FOIL or distribution, you get x squared plus 2x plus 4x. The 2x here, the 2x from the outers, and the 4x from the inners add together to give me 6x, and then my lasts are 8. So it works out when you multiply this out, it gives you back what you started. That's an easy way to check your answers. Okay, let's look at the second example here. I need two numbers that multiply to 10 and add up to 11. So what multiplies to 10? It's nice to sometimes write down your possibilities. 10 times 1 or 5 times 2. Those are two possibilities. Which one of those has a sum that adds up to 11? Okay, it's clearly the first option. So your two terms that are multiplied together are going to be x and x, because x times x is x squared, and then plus 10 and plus 1. Again, if you multiply it out, you get x times x is x squared, x times 1 is 1x, 10 times x is 10x. So the middle here, 10x, and the outers here, 1x. 10x plus 1x gives you that 11x that you need in the middle. And the 10 at the end is because the last times the last. 1 times 10 right here is 10. Let's go on and do another couple of examples. So we'll take this guy over here. So we can write down our set of parentheses. Since we start with x squared, we can put x times x, automatic. Two numbers that multiply to negative 12 and add up to 4. Okay? The only way you can multiply to a negative is if one is positive and one is negative. Okay? When you add a positive and negative number, they kind of cancel out a little bit. So let's write down our factors. So we could do 12 times 1, or we could do 6 times 2, or we could do 4 times 3. Which of these two, again, because one of them is positive and one of them is negative, we don't want them to add up to 4, we want them to have a difference of 4. So 12 and 1 don't have a difference of 4, but 6 and 2, they do have a difference of 4. So is it going to be positive 6 and negative 2, or negative 6 and positive 2? Which combination will add up to positive 4? Since the answer has to be positive 4, we know the 6 has to be positive. So we can put in a positive 6 and a negative 2. Let's check it. X times x is x squared. X times negative 2 is negative 2x. 6 times x is positive 6x. So here we have a positive 6x. Here we have a negative 2x. And we know that negative 2x combined with positive 6x is positive 4x. And the last times the last, 6 times negative 2, oops, wrong color there. 6 times negative 2 is negative 12, which gives us the last value. Alright, very last example. Here we go. If you want, you could pause the video right now and then try this on your own. So we got our set of parentheses. We got our x squared. Oh, I covered up the minus signs. We got our x squared. That tells us we want an x here and an x here. Now we're looking for two numbers that multiply to negative 10 and add up to negative 3. So what do we multiply to get 10? We could do 10 times 1. We could do 5 times 2. Again, this last number is negative, which means one number has to be positive and the other number has to be negative. And when you have one positive and one negative, instead of adding them to get the middle number, you're finding the difference. Because when you add a positive and negative, you take the difference. So which pair of numbers has a difference of 3? In fact, negative 3. It's clearly going to be the 5 and the 2. And we want the sum of these two numbers to be negative 3. So the 5 is going to have to be negative. And the 2 is going to have to be positive. Alright, let's do our last little check and then we'll be done. X times x is x squared. X times 2 is 2x. Negative 5 times x is negative 5x. So negative 5x and positive 2x combine together to give us negative 3x, which is what we wanted. And finally, negative 5 here times positive 2 here gives us the negative 10 that we wanted. So you can factor quadratics. These are called quadratic because they start with x squared. This is something we're going to learn a lot later on, but for now I just want it to kind of marinate in your mind so that when we do it later on, it won't be the first time you've seen it. So again, you're looking for two numbers that multiply to the last thing and add to the middle thing. And more importantly, for these problems, you can always check your answers by just foiling or distributing or rectangle diagramming these two polynomials. When you multiply these two together, it absolutely must give you back the starting problem. If it doesn't, you know you've done it incorrectly. So I encourage you to give these a shot, and let me know in class if you have any questions.